Hi everybody and welcome back. Um, I want to put a video together to explain what the status is of FXOS and then give you a tutorial, I guess, of how to put together an application for it. Um, I have finally decided about how the APIs would be exposed and what method would be used to get to them. And so I finally solidified it enough that you can actually write an app for it. So with the binary that I put out there, you can load the binary, and then if you put an app on an SD card, which is the only way it loads right now, um, you can put together an app, pop up a window, and not do much else because I haven't exposed the full set of the API to user mode yet. So I'll be doing that. It's just time consuming to hook them all up for application consumption rather than kernel consumption. So um, I'll be doing that, in the next week or so to get a fully functional set. But for a base application, I'll be going through that. So first off, I'll show this new about box. Um, it just explains how the system is currently configured, and that would change um, possibly on a build if things were moved around or whatever. But this just lets you know where things are currently located um, in the kernel, and what modules are where. So like the zero page, if you want to call it that, for the OS is at 1500, and that is the load information for the OS. In there is going to be the base for all of the API pointers. So you can see like the kernel is at 2AE1C. And there's DOS, the graphics, that's the drawing, and then the GUI is at 2A81C. Now, like I said, from build to build that may change, but the location um, of that is not going to change. When you reference the location where that pointer is, it's always going to be the same, um, based in the 1500 area. So that pointer gives you the entire library. It's a table of all the functions in kernel, all the functions in DOS, that kind of thing. So once you have that, you can reference it and make all your calls. Um, I've also included in here what the versions are. Now these are beta versions. I'll be resetting these all to version 1 when I actually have a final release, whenever that is. But this is just to kind of reference for me. When I change some major components, I try to group them together in the match set. So the window manager you can see is at 5, and the event manager is at 5, and that's because I did a major overhaul and um, was refactoring some things and putting them where they belonged. So they had to those things had to match because otherwise it wouldn't work. I'm going to be doing that for some other things coming up, but I mean, no one will be able to tell that from the outside. Um, so, in any case, I've exposed enough of the APIs that you can put together a skeletal application. And let's first off take a look. Right now, they have to be SD based, as I mentioned. So I'm going to open up the SD card. And what I'm doing to develop these is, I'm compiling them obviously on the PC, copying them to the SD card, and then putting them on the FMX to load. So uh, I've got several different loaders right now, hence all the different extensions. Um, but for the most part, they all function the same. So I'll go ahead and double click that, and there you go. It's a real, honest to goodness, separate application. It's not built into the kernel. It's a separate compile. Um, I've been working towards that for a while to have that be the case. I've just been testing with things that were built into the kernel, but now um, this is an actual load and run. And And as a matter of fact, you can do it again. Whoops. And you can see, if I move stuff out of the way here, they're both running there. And those are separate applications, just based on, the same load module, the same executable. So let's switch over, and we can kind of go through it. As I've mentioned in a few times, a lot of the setup of this is intentionally familiar to Windows or Amiga programmers, and it's kind of a hybrid of the two, I guess, if you can recognize it. But like I said, it's mainly to make it familiar. So if you picked up a book on Windows or you picked up a book on Amiga programming, some of these things would be familiar and you would just know what to do. Or if you've already done that in the past, you would know. So how this works is the kernel originally was interrupt driven for tasks, but I switched that up. There was a lot of context overhead, and I may go back to that if I can do a better job at it. But how it's set up, it's cooperative, like the original Windows or the Mac OS used to be. So, an application can hog the system, but, you know, friendly ones will yield and let other things run. But in any case, how this works is there's going to be the entry point, which is called um, when the app is loaded, and you can do any kind of setup here, memory allocation, that kind of thing, however you want to set that up. And then there is the event handler here, which is what the window is going to receive event-wise. So this is kind of a process loop, and this is the event loop. It's two distinct things. It's similar, but it's not the same. But in the case of this app, it's pretty simple. When it's initialized, it's going to register a window class, which is a template for a window, which allows you to make multiple copies of it that are distinct from one another, and they have their own memory space. And it defines what the process is going to be, and in this case, that's what your window proc is down here. So that's associated with this, basically a window template, window class. And then here is how the window is created. So it has the attributes for the window, the class that's going to be the template used to create the window, this, and then the initial size and location. The parent, which would be the desktop, and then some other things if you have them, which is menu and what else? If there was a menu on it. Menu and, the additional instance of it, which you could pass that in if you were tracking that kind of thing. I'll go over all of the specifics. I'm going to document these API. Like I said, it's just a tedious process, so I have to expose them all, document them, and make sure that I'm not going to change them. Hence why I haven't done as much of the documentation yet, because I have been changing things as I've changed my mind and solidified things, as I said before. So the application itself is going to get time to run outside of just the event loop processing, which is this. So it says, okay, I want to run this at some periodic rate. The operating system is going to say, okay, if you need to do calculations, now's the time to do it. And again, it's your job as the programmer to make sure it doesn't hog the system. You do what you need to do in a timely manner and then get out. If it's if you need to do something in the background or something like that outside of the UI. So again, this is application starts up, and in this case, it's going to register a window class and then create a window of that class. And if we go back here, that's what you've got here. So this is the window. Now, if we go back, we can see here's the window the procedure for this window to run, which is pretty simplistic. All it's going to do is output some things so that you can see that it actually did it, and obviously the window pops, so it's working pretty good. It just is letting you know when the window was drawn and when the window was created, and otherwise it's not telling you very much or not doing very much. In this case, if you ever return false out of the window proc, the window will close and the application will end, which is what this is. So if the button is clicked or to close the window, that's what's going to happen. Additionally, if there's messages you don't want to process, which there's a ton of them, you're not interested in them, so they're not in this switch statement. If you use the default window proc to handle the message, it will handle whatever. So non-client draws, timers, things like that, those will happen, and you don't have to do anything to do that. And again, this is a kind of a high-level tutorial or explanation. I don't even know if we're at the tutorial level yet, but just to familiarize yourself with this. So basically, that's all there is that's necessary to get a windowed app in the OS. Pretty simple. Here's the header, which is basically nothing. It's just including the other headers and saying what the entry point is. To make this work, though, you're going to have to use the WDC Tools and the library for the user. It's called fxuser, which is the user level functions, rather than the kernel level that's here. And that's something I built for the kernel that's exposing the call tables that was just displayed in that about box. So this library use those tables to make the user callable API. And if you link to this is all you need. And to get access to all of these API calls. And like I said, there'll be more of them coming up. But I was going to go through this build file a little bit just to explain what's going on. Now I realize you could use some kind of a make system or whatever, but I felt that this was more, this illustrated what was going on. It's pretty simplistic, and if you wanted to port this to Linux or something, it'd be easy enough to do. First off, you need the tools, which you can grab here. I'm going to check this version into Git, so you'll be able to get this, or you can look it up on your own. But basically what's happening here is it's just setting up the compiler options and the directories and saying where things are. So like this is used by the WDC Tools. It actually is looking for these environment variables. So if you're doing a 65816, it's looking for this environmental variable. And then you have to point it to whatever. So in this case, it's the WDC Tools include. If you're just compiling for the 6502, it's got a different set. That's just in here for completeness. I don't use that. You wouldn't use it for this. And then there's the library, which this is also used by the tool. So this is picking up any of the runtime things out of the compiler stuff, as well as this fxlib is what I've defined as being in this project. That would be like user. So it'll find all these things. This is all the path stuff that it's going to search when it builds. Needs to be set up so that to make it work properly. Then I set then I set uh, variables for the compiler, the assembler, and the linker, so you don't have to repeat that as you're using it down below. In this case, the compiler is the WDC 816CC. The assembler is the WDC 816AS. All these things come with the tools. I have another linker step here which builds the header for the loads, for the load modules. It takes care of the offsets and things. It does not do relocation at this time, but um, it will. Just right now, it statically loads. You can build the modules to different segments, and it understands that. It makes sure that when the loader loads these things, it makes sure the segment's legal for the OS, so you don't overwrite anything. But um, it will load it where you ask it to, but it won't relocate it. So if you have two things pointed at the same spot, it's going to overwrite the other one. But again, um, I'm going to work that out. Here's the linker, WDC LN. Then there's includes here, setting the includes. Now, here's an explanation of all of the options that I'm using. This is in the manual. Um, this I've found basically this is the combination that works the best. That led me to the most stable builds. Other people may have other methods, but this is the list of options that I used um, to give me the most stable build for the apps and for the OS itself. Um, the model, obviously, um, you want to make sure that everything is set up so it's far, and um, that means it has the bigger address space, as well as some of these other things are for niceties. You could shut them off, but like generating listings in the embedded source statement, it just makes debugging stuff a lot easier. You can see what the compiler spit out because um, you know I trust this compiler about 85%. So you need to see what it's doing. Like I said, this combination of options has made it fairly stable. Early on, um, it would just crash and do all kinds of crazy stuff because it was overwriting itself. I had no idea what it was doing. Um, it's important that you turn on some of these safety things so that you can see them, because it silently will ignore things and just cause crashes. So if you turn the warnings on, it gives you a heads up as to something's up that you should take a look at, because otherwise it's going to compile and you're going to run it and you think it's fine, but it's not. And again, it'll step on itself and crash. Um, so here's another one to make sure that you have turned on, which is it warns that the function return type does not match, because it'll do things like if it doesn't see the function, it just creates the function with an int return, regardless of what the function's supposed to be. So let's say you forgot to put it in the header, um, it'll just do whatever, and it'll have the wrong prototype on it, and it'll crash, and you'll spend a long time trying to figure things out. And that's what's going on. Again, here's embed source in the assembly, so you can see the match between the C and the assembly that it spits out. Debug information. This is kind of an interesting one. It assumes that arrays are less than 64K. Typically, you're going to want to shut that off, depending on what you're going to do. It's a little faster if you leave it on. This is an important one here too. This is back to what I was saying about it'll just silently do things, so it complains if the arguments do not match the prototype. That's an important one, because if you mess that up, and you don't have this set, it'll just compile fine, and then it'll crash um, randomly, and you won't know what's going on. And again, this one, if you have a function without a prototype being defined, it'll flag that too. And then it'll give you some warnings about unused local variables, which is kind of important because the stack space here on this is not unlimited, so you can't do crazy things. So if you've got stuff you don't need, you need to get rid of the garbage. Um, Anyway, so that's what those settings you're going to see down here are. I tried to list all the ones that I was using so you can see. This build is set up to do a build for the FMX. I'm going to do a U build. I actually have a B2 board, which most people don't have, but um, I can set the flag for that. There's some differences in the memory map of the hardware, so you need to be cognizant of that. But the FMX stuff is the most stable and what I'm running here. So, as a matter of fact, if I pull that back up, see, I have a C4 board. Um, Not that it matters, but that's what that relates to. Okay, here is an important thing which sets where this is going to go when it's built. So this is saying that the data and the code are going to go segment 9, starting at 0. So that's how the code is going to be based. That's where, when the executable is linked, that's where it's going to want to live. That's what all the internal references are. And right now, that's how that's statically built because it won't relocate it. So this is where your code's going to set. Um, and when the operating system calls it, it's going to look here. Now, obviously your code's not going to start right at 09, because that may not be where your main is located. It could be anywhere, but that's what the fxlink is for. It puts a header on the executable so that it will do the right thing. But anyway, that's what this is doing, and it's the most important part. Now later you'll be able to set this to 0, and then whenever it gets loaded to whatever segment it goes into, it'll fix it up. But again, that's not quite working. Libs, just like the includes. This is just the local stuff. And let's see. So down here, we're going to compile the C, and it's a two-step process here. It's going to compile the C to assembler, and then it's going to assemble it. Then it's going to link it. So it's taking our objects, adding the FX user, adding the large model libraries, and spitting out a bin. Now there's a one custom step here, which is the fxlinker, which when you do a build with the WDC stuff and it goes at like segment 09, it 0 fills the bin. So this does a couple things. It trims it, puts a header on it so that it understands the load, understands what kind of a thing it is, um, where the entry point is. It fixes all that up um, by looking at at compile time, by looking at the map file that's spit out. Um, and it does a little bit of bookkeeping. But basically, this spits out what you can run, but it just adds a little bit of bookkeeping at the top. So if you get this out of the GitHub and you get the WDC Tools, you should be able to set this up pretty quickly. It's just wherever you install it, wherever you unzip the stuff, you just need to modify the path in here. Actually, I should have this mostly separated out, but it's not. I should make a variable for that, so it makes it simpler to do for everybody. But anyway, what's going to happen is when you go to do the build here, it will show you. So I'll just go ahead and kick it off so you can see it's pretty fast. Um, and right now I've got the linker turned off, so that's why it's doing that. But so it built it, put it at segment 09. It's pretty small, 1803. And then what this is doing is it's just showing you what it was you built. So here's the entry point, and here's all the things that it saw from the user lib that being linked in. You can see all those. Those are basically all the exports um, that it picked up when it was doing the build. And here's your data section here. Again, it's pretty simple to get it working. Once you do this, you should be able to take the binary for the OS, push it to the board, and then when you stick the SD card with this in it, you should be able to do what I was doing with the see if everything behaves properly. Yep. And start that up. There's another copy of it. So it works pretty well. Like I said, this is going to be updated as I go. I just wanted to put something out there. I'm going to refine it. I'll put the steps and why things are where, and you know what you need to do to make it work, um, as well as start exposing and more of the OS API calls, so you can do things with it. Like I said, right now it's just kind of a novelty where you can write an app that it will load, and um, I'm just pretty happy that I got that far. I finally made up my mind about how the APIs were going to be called, and I'll go through all of that later. But this one, I just wanted to I put that GitHub out here for anybody who was interested in writing apps a few days ago, and I hadn't had any kind of follow up or instructions on how to use it. So keep watching that GitHub page, and I will keep updating it with useful information, I hope, and then I'll start documenting the APIs and all that fun stuff. But anyway, I hope you liked the video. Hope it didn't ramble too much. If you have any questions, put them in the comments. I'll be watching and covering anything that needs to be covered. Thanks. I'll talk to you later.